Right, in this video I'm going to show you how you can make a low cost, high quality electronic compound drive finishing tool for the lathe using one of these 12 volt DC worm drive gearboxes. Now you can buy these gearboxes and motors, the whole assembly on eBay from China for under £6, and that includes postage. And they're a worm drive gearbox, so they have very high torque. They're often used for powered hoists and other applications like that. And like I said, they're low cost, good quality, and very good for this tool that I'm about to show you. Now when you buy these assemblies from China, you have to choose from a factory set RPM. Now there's a good variety of spindle speeds to choose from. I chose 30 RPM, which is ideal for this tool, but like I said, there's a good variety of spindle speeds to choose from, and when you get them through, it's marked on the side DC 12 volt. This one's 100 RPM, and like I say, this one is 30 RPM. So the motor is permanently fixed to the gearbox, and there's four 3mm threaded holes for location. And whenever I buy a new assembly like this, I always like to take one apart to see what the quality is like inside. I've removed the four countersunk screws on the top plate there. The top plate lifts off complete with the spindle and gears, and you can see inside that it's got good solid steel and brass gear assembly mounted on brass. The back of the spindle has a brass bush or a bronze bush as well, and it's all well lubricated inside with silicone grease, and the actual worm drive on the motor shaft is brass as well. So like I said, it's a good quality all-round component and easy to maintain. And you can even buy these motors with straight setup gearbox like this one here. I chose this style particularly for the actual tool that I'm using, so that I can use the tool in confined spaces on the mini lathe or the Myford lathe. So all that you need besides this motor and gearbox to make this tool that I'm about to show you is some 30mm diameter PVC bar or plastic or nylon bar, a momentary push button on switch, small switch there like that one, a panel mounted socket 2.1mm DC power socket, a plastic wire connector, a piece of aluminium that's about 2mm thick, and you can bend into a right angle like this, or you can use brass or steel, and obviously the 12 volt DC power socket that you get on most like hubs or whatever, or you can just buy them on eBay as they are separately, and obviously some electrical wiring. So now on the mini lathe, I'll just show you how easy it is to make the main housing assembly for this tool and the handle. Right, I have the 30mm diameter PVC bar. I've faced off both ends to around 83mm, and I've drilled through halfway with a 19mm drill, and now I'm going to drill through from the other end to meet that hole. So now I'm going to bore halfway through so that the bore here is a nice tight push fit on the housing motor. And I'm going to be using this tool here, which I've set at 45mm from the end of the tool to the tool post. So when it's the right diameter, the motor housing is a nice tight push fit. You have to turn it and push it all the way down, and that will prevent the assembly from falling out of the plastic handle and save any need for any locking screws. So next it's turn the bar around, and using the same boring bar, bore out this end to the same diameter as the front, or you can do it a bit smaller, and whatever you turn this bore to, you can make the end cap to fit that with a nice push fit. But you want it roughly the same diameter to give yourself enough room for the wiring and the connector. So to save time, I've just finished that bore, and I've done mine to 0.945 inch diameter. Reasonably good finish. It doesn't matter about concentricity. And now I'll just make up an end cap to fit that one, drill the end cap for the female plug socket. So for the end cap is a piece of 30mm bar, PVC bar, about 20mm long, and just face off both ends. And turn the diameter to suit the tube by about 10mm deep. And when that's the right diameter, that's a nice push fit as well. Next I set the boring bar to a depth on a stop, so it goes about 5 or 6 mil beyond this shoulder, so it's about 17 or 18 mil deep. And then bore out the centre to give clearance for the plug and wires when they come through. Just leaving about 0.1 thou wall thickness. So it looks like that. And then turn it round in the jaws. And I can part off some of the excess material. And then just face off the end to clean up. And deburr the corner. So that's the end cap finished. There's a thin wall at the back here and the clearance for the socket to go down through, and it pushes through from the inside, and then the nut and washer screws on this end hold it captive in that piece. So that's the machining finished on the lathe. Incidentally, if you do make the end cap and just say that it's very slightly loose, you can actually put a cone tool in there in the vise, wind the vise up so it expands it slightly, and apply a little bit of heat with a heat gun, and that normally will make it a little bit bigger on the diameter, and you can actually re-skim it to get a really nice fit. So like I say, if you make it too loose, there's easy ways of rectifying it. Now halfway down, or just over halfway down from this end here, this is the cap end, there's a hole drilled here, and I put the PVC in an ordinary vise drilled through with a 5mm drill, and as it went through I tilted the drill over to give a bit of an angle on there, and after that I deburred with a like a cone tool, and deburred the inside with one of these tools here. So to save time, I've soldered the wires on to the motor, the switch and the power socket, and now the wires are fed down through the handle and the handle housing is pushed over the motor, a nice tight fit, and you can see why I had this hole back here, and that's for the wiring to go through, and it's drilled so there's plenty of clearance from the actual end face of the housing of the motor. So next I've got this soft piece of aluminium flat bar, 2mm thick, bent it at a right angle, drilled 2 holes for the screws, and that will go on the gearbox there like that. I'll just screw that one on. Nice and tight like that. And that's the bracket for the switch holder. That wants to be turned round that way like that. And then the momentary switch, or the push button switch, feeds through the top of that bracket. I think it's about oh no, it feeds through from the underside there like that. And then the locking washer and nut on the top. Like that. So next the switch wires are fed down through the side hole. Incidentally, when you solder these wires on, make sure that they're long enough to clear the length of the actual handle. So that's pushed down through the housing and comes out the end there like that, and that's why I had an angle on the hole there with the drill, so it feeds in nicely. So next you take the positive wire from the motor, just check that one a minute. So yeah, the positive wire from the motor, and connect that one to one of the wires from the push button switch. You can obviously use a proper connector, but I just wind them together, bend it over, and then put some electrical tape around that. And then the other wire from the push button switch goes into the actual connector block. And then take the negative wire and put it in the other side of the connector. Tighten that up nice and tight, and that's that done. A bit of tape around the bare wires there. And then the DC power socket goes to the end cap, locking washer and nut. And tighten that one up. And connect that one up to the connector. And that one's all wired up. And before I push it all together, I plug in the socket and give it a test drive. So that's all good. And then all the wiring is pushed up inside the handle with the connector. And push the end cap on, and that's nearly finished. Next, my aluminium drive adapter goes on to the spindle. I've got a 6mm grub screw in there for locking down onto the flat of the spindle. And that's all ready to go on the lathe. And you can actually finish it off if you want to. You can actually put a bit of cycle inner tube down over the whole thing to cover up the wires, or a bit of heat shrink if they do that size. I'm not sure whether they do that size, but like I say, a bit of inner tube is fine to cover up that, or some electrical tape. And to finish off, this is one I made earlier. I've used my sticker machine to put the RPM DC 12 volt. And this is the tool in use on the Myford ML7. And there's no need to have reverse on the tool because you wind out and wind back fast. and you can see what a lovely finish that has done on that angle. Continuous feed, lovely finish, and a great tool to have. And there we have it. I hope you enjoyed the video, and see you next time.